Right, the purpose of this video is to outline the experiments that I normally carry out when I teach the topic of length and time to the IGCSE students. Now the first one that is lined up is to find the thickness of one sheet of paper with say 100 sheets. Then the area of the page, the diameter of a small ball bearing, finding the circumference of a test tube, and finding the circumference of a disc. Right, so first of all, I'll start with finding the thickness of one sheet of paper. So here I have 100 sheets of lined paper, which I'm going to use the meter rule to find the thickness of 100 sheets, and then I'll use the Vania side calipers to measure the same. Right, from here I've positioned the meter rule to be perpendicular to the plane of the papers. As I can read here, remember the meter rule measures to an accuracy of 1 millimeter, and what my eye can see there is about 7 millimeters. Now I'm going to measure the thickness of the sheets using a Vania side calipers, but first of all I need to ascertain the zero error of the instrument. And as you can see, as with the jaws closed, the two scales are coinciding. There is no zero error. As you can see there. Right. Now with the jaws on the sheets of paper, I'm going to take down the reading. Right, that should be 7. Let's see, 7.3, because they are exactly coinciding at 3 there on the Vania scale. So 7.3 millimeters. So I'll write down the measurements. So recording the measurements from the meter rule. I recorded 7 millimeters. Right. So that's one significant figure. And then with the Vania, that's 7.3 millimeters. So it shows that I can achieve 1 SF with the meter rule, but the Vania goes beyond the 1 SF, which to give us a more precise reading, that is 7.3 millimeters. Now to convert these into centimeters, this one will be 0.7 centimeters, and then this one will be 0.73 centimeters. Now the second experiment is to measure the area of a page. So I'm going to take one of the lined sheets, and then measure the length and the width using the meter rule, and then we're going to find out what we're going to get. Right, I'll put my meter rule so that it's exactly parallel to the paper, and I'll start right on the edge so that I don't have any zero error, which would be called dead space if it's a meter rule. So according to this one here, I've got 29.7 centimeters. Right, so I'll record it down. It's 29.7 centimeters. Now I have to measure the width. It's at 29. Right, the width is 21, yes, 21.0. 21.0. So I've recorded it as 21.0 centimeters there. So I found the area, and it is 623.7 square centimeters. Now moving on to the third experiment, finding the diameter of a small ball bearing. So what I'm going to do is I'll place 10 ball bearings in a line against a millimeter scale. And then I'm going to use wooden blocks or set squares to hold them in place. I think I'm going to use wooden blocks here. Then divide the length by 1 to find the diameter of, by 10 to find the diameter of one ball bearing. Then I'm going to proceed and use the micrometer screw gauge to find the diameter of one ball bearing at once. Right, I have my ball bearings lined up, 10 of them there. So what I'm going to do, I'll take the reading on my left hand side, which will be 75.8 there, and then on the right hand side it's exactly at 87.0, right? And then I'll subtract the smaller one from the bigger one, then divide by 10. Right, so the highest reading I've recorded, and the lowest reading, and the difference is 11.2 centimeters. Now to get the diameter of one, it will be 11.2 divided by 10 ball bearings, which should give us 1.12 centimeters. Now using the micrometer screw gauge, again as our precaution, we need to close the spindle, and then we take down the zero error, and according to this one there is no zero error. Right, so taking down the reading with the ball bearing in the spindle face, we have 11.11 millimeters shown there. So the micrometer reading was 11.12. Is 1.11 centimeters. That is to two decimal places. Please watch my part 2 video on the fourth and the fifth experiment. That is finding the circumference of the test tube using a fine thread, and then also the circumference of a disc. Please don't forget to subscribe, to like.